Okay, now, first of all, I noticed that those people, even people who almost always get things done, didn't do this full assignment. I think it was due last night. Okay. Maybe I have it at the wrong date, so if it's not due yet, go ahead and do it. Otherwise, be sure you go out to the half credit page at least and do this. Okay. Really need to do the assignment. It's something you do real well on it. So whether you've done the assignment or not, maybe you remember what we did in class last time. That'd be even better. Okay. Now, the problem people are having is they don't seem to know the formula for the sum of two squares or the sum and difference of two quantities. Well, I gave you the hint, the product for this and the product for this. You should always know this and this. And then, now y'all have been pretty good with distributive law, but today it must be something in the air because I'm seeing some difficulty with it. Okay. So let's say that we have, how do you get the special product? Let's say we have A plus B times A plus B. What's that equal to? That equals A multiplied by A plus B plus B multiplied by A plus B. You can see open math do this and this and this and this. That's fine, but that gets pretty confusing if you got four of them here and four of them there. Okay, you want to be able to write it out using the rules, which you've seen me do multiple times. So you need to pick up on it. Here's what the rule says. This isn't what the rule says. This is what the rule says. Now, this is a representation. It's equivalent to what the rule says, but this ain't the rule. Okay? This is totally impractical if you've got more than two or three things in each set of parentheses. Okay? Not totally. If you're really good at keeping track of connections, you might be able to do it, but this is the way it needs to be written out. And then this is A times A plus A times B plus B times A plus B times B, which is A squared plus AB plus AB plus B squared. The only thing I did in this step is I replaced A times B with B times A. And of course, I'm not recording, so none of this incredible insight. Oh, never mind. There it is. It really is going on there. Okay. Grader's going to have to go back over that, lose all the inspiration. Okay, well, anyhow, you understand what I'm saying? Every step, you've seen me do every step. You need to be able to do every step. On the exam, I'm going to ask you to do every step. Okay? If you can't do every step meticulously, then you're on shifting sands when you're trying to do this stuff. Okay? You're not on solid ground. And it's really easy. You just, I understand. You don't want to take the time. You just do it like this, and you never establish the distributive law. Okay? You haven't been writing it out like this, and I've seen you do it. I've seen everybody do it, but you probably haven't done it often enough. It's stuck with you over long weekends. Okay? That's why you write it out in detail. In any case, you get this formula. Okay. And then when you do this with A minus B times A plus B, that's A times A plus B. Sorry, minus B times A plus B, which equals A times A plus A times B minus B times A minus B times B, which is A squared plus AB minus AB minus B squared, which equals A squared minus B squared, because AB minus AB equals 0. If I ask you to write this out in detail, there's a very good chance that I will. I don't want anything to be left out. I want you to understand this stuff at a very fundamental level because you use it all the time. And if you don't keep track of it, well, it's going to cause you problems that I'd rather see you not have. Okay. Going to get in your way. You're going to stumble over things. Now, your bottom line is you should remember this formula that this is equal to this. But you should always be able to verify it by multiplying it out using the distributor. And if you know that you can write out every step, sure, go ahead and shortcut it if you're in the middle of an assignment and you know you can write out every step, shortcut it whatever way works for you. But what I'm saying is, in most cases, you're spending more time on it than you would if you wrote out every step. Okay. Start by writing out every step. Then shortcut it when you know where you can do that. All right. Well, and a lesson on how to do this, how to remember it. But you then have those are the two special products that we use to simplify these. Okay. Now, so 49x squared y to the 6 minus 81x to the 4 y squared. You have two alternative ways you can do this. Okay. One way is to show that this is 7xy cubed squared. Okay. Square root of 49 is 7. Square root of x squared is square root of y to the 6 is y to the third. And you can double check that. Y to the third squared gives you y to the 6th. X squared gives you x squared. 7 squared gives you 49. Okay. And then over here, you can say, well, that's minus then the quantity 9x squared y. Well, that's a squared minus b squared. With a equals 7xy cubed and b equal 9x squared y. So that gives you a minus b, okay? I wrote it a plus b times a minus b here. I wrote it a minus b times a plus b here. Doesn't matter which way you write it out, just be sure you know which way you're writing it out. Pass it on, okay? So we have this product. And then we can use the distributive law to check this. Okay. And it'll work out. Now, you should use the distributive law. You should check it. You should be using the distributive law every chance you get. Remember, the object is not get through the homework and get through points as quick as possible. It's get through the homework and learn the stuff as well as possible. Okay? Now, I noticed that some people started this assignment but didn't finish it. Yeah, could be because you ran into difficulty. This whole thing of factoring is new. Okay? So that's kind of par for the course. Go back and finish it all the way to writing out clearly how you're using these things. I recommend you write it out the same way I do, unless you can think of a better way. Okay? Remember, a better way is not the easier way. It might be. But the better way is not the way of skipping a bunch of steps. Because you skipped them before and it worked, and now you're skipping them again, but you're not sure why it worked. Okay? Or you're following some template, which you ought to have somewhere at least 5 miles away from you when you do these problems. Okay? That's how you learn it. Unfortunately, this isn't that difficult. If you write it out the way I'm saying, or in some way where you're writing every step and seeing how everything fits together, then you're going to learn. Okay? Just a matter of taking the time and disciplining yourself to avoid shortcuts in the learning process. Okay. Now that's this one. Now there's another way that some of you did this one, and actually it's preferable. Okay. Alternative, you got 49 x squared y to the 6th minus 81 x to the 4th y squared. You should see that you can factor out x squared y squared. Okay. Because of course you completed that assignment, and everybody did quite well in that assignment. So I hope you have retained what you knew about that assignment when you did it. But that's very straightforward. You can again use the distributive law, x squared y squared times y to the 6th. Oops. You know, it's a good thing I checked. Y squared times y to the 6th isn't y to the 6th, is it? Y to the x squared times y to the 4th gives you y to the 6th. I really made that mistake. Yeah. Busy talking, I write down things going by, get to something. I got that one right. No, I didn't. That should be x squared. So you see, when I come back here and talk about checking it, I catch myself. Okay? So x squared y squared times y to the 4th. Well, y squared times y to the 4th is x to the 6th. And you don't have an x here, so you just get your x squared. Okay? Similarly over here, x squared times x squared equals the x squared. You need the y squared, but you got it there. Make sense? Now, having done that, make a briefer annotation, although I recommend that you write it out in a little more detail. But here, your a is 7y squared, and your b is 9x. If you square this, you get this. If you square this, you get this. So you get x squared y squared times 7y squared minus 9x, 7y squared plus 9x. And of course, here's your a minus b, and here's your a plus b. Seven y squared b equals 9x. If we then look back up here, it gets a little harder to factor out that x squared y squared because everything is tied up here. But this is actually a better factored form than this is. Although I'm happy if I saw this. Okay. I'm even happier if I see this. I think I saw that. The key is factor out the monomials. Okay. Saying that is factor out the monomials, match up with the special product if possible, write out all the steps. Okay. Do that. You're going to find this isn't hard at all. After you beat your head against the concrete wall, it turns out that all of a sudden you see it. You're there, the wall collapses. Okay. And then you pretty much have it. And if you need it later, you might forget the details, but a quick review and bring it back to you. Okay. There are only not even two handfuls of rules you got to remember. Everything is built up from those rules. So you really want to work in a way that makes you understand those rules so that you can put the pieces together. Okay. It's kind of like a game, although it's probably not as fun as a lot of games. It is rewards when you learn how to do it. Okay. Now, let's take a little quicker look at the others. We have x squared plus 7xy. Plus squared. Well, you know, there isn't a special product. Okay. Kind of threw that in. Because hopefully you can factor this thing. It's a binomial. Okay, and we actually, let me check some. I've rearranged the order of assignments so many times due to the interruptions we've had that I'm not even sure what the sequence is. Quickly to recapitulate, because I wasn't recording that. We have x squared plus 7xy plus 6y squared. Now, when I said factor using special product, okay, I said that, but then I wrote one down. It's just a trinomial, including coefficient 1, that hopefully you could factor. Some of you did. Okay. But it's a little bit of a curveball. I threw it out. See what you do with it. And a lot of them did pretty well with it. Okay. Now, I know that I can write this as x plus 6y times x plus y, maybe, because that gives me the x squared, and the 6y times y gives me the 6y squared, right? Now, whether we get the 7xy or not, we'll have to see. I could also write out x minus 6y times x minus y, but I disregard that because I'm going to get a minus xy here and minus xy from here. And they're both going to be negative. We're never going to get a plus 7xy. two negatives there. It could be x plus 2y times x plus 3y. Okay, it's another possibility. Because 2y times 3y gives us a 6y squared, and x times x gives us n squared. Well, and then that x minus 2y, x minus 3y, not going to work because that's going to give us a negative in front of the xy. Okay, so we just take the first one of these. We don't know which one's going to work. Actually, maybe we have a pretty good idea which one's going to work. We still want to use the distributive law, write it out and verify it. So we write out x plus 6y times x plus y, x times x plus y, 6y times x plus y. We do the arithmetic, we add it up, and there it is, without any skip steps. Okay. So not only have we verified that we factored it correctly, or that this is a correct factorization, so we cross out the rest of the possibilities. We've also practiced the distributive law, which we need to do, as you're always going to need it. Okay. Well, going to the last problem that I have to do, you got 32 x squared minus 18 y to the fourth. Okay, we're still on the screen, yeah. Okay, so if we can factor with special products, we basically got these three steps. You want to start by factoring out whatever monomial you can. In this case, the only thing that really factors out, these are both even numbers. We factor out 2. And we get 2 times 16x squared minus 9y to the fourth. I didn't necessarily expect you to see the factor out the monomial in case of the first problem, although some people did, and that was very good. And because last week you had the assignment of factoring out monomials. Okay. And that stuck with you, and you did that. That was very good. And that really is the preferred way for a lot of reasons. After you factor out the monomial, what you're looking at is a lot simpler than what would be if you didn't factor. Also, you get a more complete factorization. Okay, so now, okay, this is, I'll say A equals 4x, B equals 3y squared. So this is A squared minus B squared. Just gotta make that little note here. A minus B squared, A equals 4x, B equals 3y squared. Write that step out. Don't get in a hurry and skip it until you've done 100 of these. Okay. You know, there are two alternatives when giving an assignment of this stuff. I give you 100 problems. I know that after the first half dozen or so, you're going to get the gist of it, and you're going to be able to do the last 94 almost as quickly as you did the first 6. Okay? But if we use a shorter assignment, it asks you to write out all the steps and reinforce it. It's both quicker than doing 100 problems, and you actually recall it better instead of just doing it by hand. Okay, you learn the principles. That's what you really need to be able to do. Okay, now if you want to practice a bunch of problems, OpenMath will let you practice to your heart's content. Okay, and if you think you can learn better doing that, go ahead. So you don't have to do it the way I'm saying. I'm just giving you a recommendation that I think will work best for the majority of people. Okay, now, again, we've factored out our monomial. We've identified that we have a square of 4x and a square of 3y squared, so that we get 2 times 4x minus 3y squared times 4x plus 3y squared. Which of course is a minus b times a plus b. Okay, so to repeat myself for the 50th time, there is a step before you factor out the binomials, which is to know what the special products are. And if all you remember is one of them's for a plus b squared, the other for a minus b times a plus b, you just apply the distributive law and out pops your formula, right? Okay. Now here we see that we've got a squared minus b squared. You see that we've got a minus b times a plus b. That's our application of the formula. Many ways you can write that out, many ways you can structure it on your page. The file means structure it on your page so the thinking is transparent to anybody who looks at it. Most importantly to you when you look at it to review for the exam. Okay? Scattered all over the page. You're going to waste 2/3 of your effort figuring out why to put that there, why to put that there. Structure it. Be explicit with every step. When you're reviewing, you might say, okay, I'm safe skipping that step on the exam. But I ought to do it in my head. And learn to do it. Okay. Well, need to move on to another topic. But if you need more practice on this, or if you need to actually complete the thing and haven't completed it, more practice, Open Math stays open for practice. Okay. If you haven't done it, you want the credit, go to the half credit page, get half credit. Okay, now I did this distributive law in my head, which means I took a chance. Things might work and it might not, but we're going to find out. Okay. So I want to start with this expression and pretend we don't know this. Okay, I don't remember what it was, do you? How are we going to factor this? So what we want to do is now the trial and error methods. And incidentally, Open Math gives you tricks, gives you a formula you can follow to factor these things. We have a monic polynomial of 1 in front of the x squared, okay? And I don't like to even talk about that trick. All right? Because it's just a trick. And if you don't understand where the trick comes from, I don't think it's profitable to know it or to use it. Okay? I think you learn more by reversing the distributive law. When it comes to these, there's a trick that Open Math gives you, okay? And as far as I'm concerned, you're welcome to use that trick because the alternative in this case gets pretty complicated. So I'm going to show you why that trick can be useful and why it's probably better than driving yourself nuts with 40 different possibilities. Okay, so I'm just going to do this. Now, this is actually fairly straightforward. This is going to equal something times something. Okay. Now we might have 6x here and x here. Okay. Or we could have 3x here, 2x here. Those are the only possibilities if we're going to factor this over the integers. It'll get whole numbers and stuff. And negative. Okay. Make sense? Now, using this form, we can try the following. Down a few times. Okay. Now we got to get -6 over here, right? How could we get -6? Well, we do -1 here and +6 here. We could do -6 and +1. Okay. Both ways we would get -6 and we get 6x squared. Right? Or we could do -2 + 3 +3 -2. Are there any other possibilities? Well, yeah. But actually, I did. Let's just stick with my scheme where I have a minus over here and a plus over here. Okay. Well, I can write every one of these, but switch the two signs. So I could also write just write out the form here. Every one of these. And I'm going to use the same numbers here. 1, 6, 2, 3. Then I'm going to make them plus instead of minus. Okay. And then over here, same numbers in the same order, so they're sure to multiply out to 6. But with minus, we get to -6. Like there's 8 possibilities. We can use a distributive law to check out every one of these possibilities, and hopefully one of them will match this. Okay? And it's actually not that hard because we know that this times this and this times this, they better come out 5, right? But -1x and 36x isn't going to give us 5, right? And -6x and +6x, the x's go away. Okay, that one ends up actually being of a minus b times a plus b form if we factor out the 6 over it. But we're not going to worry about that. Okay, that gives us a -2x and an 18x. That ain't going to give us 5x. And 2 times 6x is 12x. Subtracting 3x, it's not going to give us 5x. So we can really check those out pretty quickly if we think about it. Now step in that direction. And yeah, go ahead and do the distributive law on these. And pretty soon you'll see that if the number you get on the x squared is too big, there's no way you're going to end up with a 5x. Okay, well, same thing over here. You're going to get a -36x. Here you got a 6x and a -6x, which turns out to be essentially the same thing this is. Here you got -18x, that's not going to be interesting. Here you got -12x and 3x. It's not going to be any. Okay. Matter of fact, if these don't work, none of these are going to work either. Okay. Unless one of these will give you -5x, in which case this will give split. Well, you can play around with those possibilities. All right. Does that seem like fun? Doesn't seem like that much fun, although it's kind of good for your soul to do a couple of them. So that you appreciate the trick. Well, we can go over here using plus something, 2x plus something. Well, we can write down a few of those. Okay. So let's go ahead and put in the same numbers we did over here, -1, -6, -2, -3, and then +6, +1, +3, +2. In each case, you're going to get a -6, this number and this number. Six times 3x is 18x, and -2x is not going to give us 5x. Write these out. It's clear it's not going to work. Here we have a -12x and a 3x. It's going to give us a -9x. That's not going to work. Okay, here we have a -4x and a +9x. Well, you know, that looks like it works at first glance. We got -4x there, right? -2 times 2x, and 3 times 3x is 9x. So that looks like it might be worth multiplying out to make sure. And then here we have a -6x and a +6x. I like it as just that doesn't give us it. Okay. So let's try. I want to check this out. So it's 3 times this minus 2 times this. That's going to be 6x plus 9x minus 4x minus 6. And that equals 6x squared. Square of it. Plus 5x minus 6. There we got it. Now, if this number is like 36 and this number is like 24, 36 could be 1 times 36, 2 times 18, 3 times 12, 4 times 3, or 6 times 6, 4 times, wait, 4 times 12, 4 times 9, or 6 times 6. Okay? And it could be plus or minus. You see that you'd have a whole paper full of possibilities. So you're going to want that trick to open math gives you. Okay? And I find that when people use that trick, they generally get these number right. Almost everybody makes them for zero. Okay? Or at least 90%. So I'm not going to go over that trick because if I do, I'm going to explain why it works. And nobody's going to remember why it works. Okay? It's a little complicated. it's more complicated than anything I'd expect you to be able to do in this course, to understand why the rule works. It's a little more than I even expect you to do on the exam, to remember the rule, why it works. So if you end up having to factor something like this, I'm going to have at least a good hint about what the rule is. Okay. So I'm not going to expect you to have to do all this. But I do recommend you do this for a couple of problems just to gain a little practice. It's a little tedious. Pick something that doesn't have more than a couple of factors here, a couple of factors here. Like 6 could be either 6 times 1 or 3 times 2. Use 36, well, you got 5 different possibilities. And that gets unmanageable. Okay. So take that for what it's worth. I want to move on forward to the idea of using factoring to solve equations. So I ask you to solve this equation. Now, you already know a way to solve this equation, I think. Okay, so if I give you this equation and ask you to solve it, I started to say, well, there's another way that you might know because I never remember when it is we did the quadratic formula in this class. But it's coming up. We haven't done it. Okay. So one way is to recognize this is a quadratic equation. Don't worry about that right now. It's easy to recognize. Okay. And it's real easy to do once you got the formula. So not knowing that, what we do is we factor this equation, giving us x plus 2 times x plus 2 equals 0. Okay. Now, can anybody give me a value of x that would make that equation true? Okay, again, given this equation, it can be solved using the quadratic formula, but we haven't covered that yet. We will within the next couple of weeks. It's pretty easy. Okay. But we can factor. We factor this into x plus 3 times x plus 2 equals 0. I asked what x might make this true. I got the suggestion about x equals 0. That's not a bad suggestion, okay? Turns out it doesn't work, but let's check out why. If x equals 0, then x plus 3 times x plus 2 equals 0 becomes 0 plus 3 times 0 plus 2 equals 0. And 0 plus 3 is 3, 0 plus 2 is 2, and 3 times 2 is 6. So 6 isn't equal to 0. So nice try, but no, that didn't give us 0. Okay. Now, turn this off a minute, see if anybody else has a suggestion. Let's see. Okay, we got one suggestion, which was, I don't think it might have to be a negative number. Well, bingo, it does. Now, what negative number? Well, somebody else said, -2. Let's try it. Okay. That becomes -2 plus 3 plus -3 plus 2 equals 0, right? Is that going to give you 0? Plus -2 plus 3 is 1, negative 2 plus 2 is 0. And 1 times 0 is 0. So, and anybody else, if you made that suggestion, negative 2, you already have as much glory as one person can stand today. So let somebody else make a suggestion. And I swear my finger was an inch away from the trackpad and the stupid thing moved. So negative 3 also works. The big question is, do I have anything to write on? Well, that'd be the back of the board. So I'm going to make a note down here, and then we'll work it out the way we usually write it. I'm saying down here is x equals negative 3 also works, since negative 3 plus 3 equals 0. That might be a little hard to read. I had to go loud enough. But let's rewrite the equation now that we've seen that much. Okay, so we have x squared plus 5x plus 6 equals 0. We factor, you get x plus 3 times x plus 2 equals 0. Now our reasoning is if x is negative 2, this is going to be 0. And we multiply by this and we get 0, right? If x is negative 3, this is going to be 0. We multiply it by 2 and we get 0. So what we do is we say, this product is going to be 0 if and only if x plus 3 equals 0 or x plus 2 equals 6. And we don't say x plus 3 equals 0 and x plus 2 equals 0 because they can't both be 0 for the same value of x. One or the other can be 0. So we're right. We've already seen something like this. Does that remind you of absolute values? It should. Okay, it's got an or there. The logic of this statement and this logic are important. And I hope that you repeat this logic when you write things rather than just doing the expedient thing and slopping down a solution. I understand if you have so much time pressure, that's all you can do. I did my share of it too, but I was always digging to make sure I understood it. Okay, to make sure you do as much as time permits. Okay, anyhow, x plus 2 equals 0. 3. Well, you can solve this equation. Get x equals 0, yeah, you get x equals -3. Okay? Not write out the steps because equations are not always trivial. That word or in there every time, because the distinction between and or becomes real important in some cases. So we want to get on the right track. I told you the same thing about absolute values. Many of you picked it up, okay? Not everybody did. And then not everybody did absolute values correctly, but most people did. Okay? I don't think we did. So anyhow, there we have it. X equals 3 or x equals -2. Okay. Now, the reason I include the algebra is when you factor something, you might end up with something like 2x plus 4 times 3x minus 7 equals 0. That's into 2x plus 4 equals 0, or 3x minus 7 equals 0. And here you got to do a little bit of arithmetic. Not writing out all the steps, but you see, you might have to do a little bit of solving of linear equations. Okay. And sometimes these equations aren't even linear, but we haven't crossed that bridge yet. So again, I recommend when you write out your homework, you write it out in this form. Now, this assignment isn't yet assigned, but I recommend you kind of read ahead a little bit and ponder it if you have time. Between Tuesday and Thursday, if you don't have time, I certainly understand that. But it would be to your benefit to at least spend 5 minutes thinking about it, if you can spare that. Okay?